the third problem of today's Leetcode contest. We are given an array time where each array element denotes the time required by that bus to complete one trip. And what we need to do is we need to find the minimum number of time required for all the buses to complete at least this many number of trips. So for example, 1, 2, 3, it denotes that first bus requires 1 unit of time to complete one trip. Similarly, second bus required 2 units of time to complete one trip. And third bus required 3 units of time to complete one trip. And we need to complete total 5 number of trips. And we need to find out what is the minimum number of minimum time in which 5 trips can be completed by all the buses combined. So at t equals to 1, we can see that first bus will complete one trip and second bus and third bus will not be able to complete any trips because they require higher amount of time. At t equals to 2, second bus would be completing one trip and first bus by then would have completed 2 trips. And similarly at t equals to 3, first bus would have completed 3 trips, second bus one trip, and third bus also would have completed one trip. So at t equals to 3, you can see we have completed total trips of 5, and that's what we have to find. So this is the minimum time which will be required to complete 5 trips by these 3 buses. So one simple solution could be to just implement whatever is written in the explanation. Basically, we will go at each time, calculate what are the total number of trips that has been completed, and if it is greater than or equals to this, we will just stop there and return that time. So let's implement this. Uh, let's say what we want is basically uh, calculate this array for each time. So we like let's say you have an array, maybe some xyz, and you are given a time t. So how will you find out with like how many trips this bus would have completed? It will be simply t by x of a floor of t by x, right? Because these many number of trips would have completed by the first bus because first bus required x unit of time to complete one trip. So let's implement this function wherein we will we'll calculate total completed trips, and we will be given time, and we will also be given current time. So as discussed, for each bus this will be the number of trips that that bus will complete. So we will just iterate over the time and add this to our answer. Now in this, as discussed, we will start with t equals to 1, maybe ll, and maybe go till 1e14, basically 10 to the power 14. Why 10 to the power 14? Because total trips required is 10 to the power 7 maximum, and each bus can take maximum of 10 to the power 7 time. So in worst case, there will be only one bus which has to complete these many trips, and that bus itself requires largest amount of time to complete the trip. So that bus will require 10 to the power 7 time to complete one trip, and it is the only bus, so it has to complete total 10 to the power 7 trips. So in total that bus will require 10 to the power 14 trips to have been completed. So now we will just check whether total completed trips until time t, if it is greater than equals to total trips, we will just return t. Otherwise we will continue, and this we will never come outside this loop because would have returned something from this loop. So this is just a dummy value. So if we run this code, you can see this is giving us correct output, but this is not efficient. Like if we try to submit this solution, it will be time limit exceeded because clearly we are this loop is very huge, like 10 to the power 14. So what we can do to optimize this? So to optimize this, we can see, let's say, at time t. So it is clear that we can't iterate over each of these time, right? So let's say at time t1, uh, total trips required, total trips completed at time t1 is equals to, let's say, x. Now, if x is less than total number of trips, so what you can guess, like what you can derive from this condition. So total trips completed until time t is less than the total trips we actually require. So our answer will lie in this part of the in this part, right? And similarly, if x would have greater than equals to total trips, then our answer would have lied here, because we basically here we know that at time t1 the total number of trips is greater than equals to. So either this can be our answer, or there is something before which also, like at that time also we could have completed this total number of trips. So our answer will lie here. So I think it will look familiar to you. It is binary search because this function is increasing. So let's try to optimize this loop. We will just implement this. So if and m is equals to l plus r by 2. Now if total trips completed until m is greater than equals to total trips, then our answer will lie here. So l will remain the same, but r, instead of pointing here, it should point to here. So r is equals to m. Otherwise, we know that our answer lies here. So basically r remains the same and l will be m plus 1. And at the end, we will just return l. Basically l will be equals to r, so it doesn't matter what you will return. So this is correct. Now, thank you.